Hello, everyone. Welcome back. We are covering 2.6, the very last section of Chapter 2, which means you will be having an exam coming up pretty soon. Okay, so let's go ahead and get started here. 2.6, graphs of functions. So in this video, I am going to cover the background for graphing functions using translations. And then in part 2, I will do 5 examples. Okay. All right. So before we get started with the actual translations, I would like for you guys to memorize 3 particular graphs. Okay. So the graph of x squared, the graph of x cubed, and the graph of absolute value of x. Okay. We're going to graph these by looking at 3 points, making a table of value of 3 points. But just like in the last section where we looked at how to graph a line just by analyzing the equation, that's what we're eventually going to be doing here in 2.6. So we are going to be looking at the equation, analyzing it, and extracting information about how to graph it instead of making a table of values. But we haven't looked at these actual graphs using a table of values. So that's what I'm going to do right now is look at 3 particular points, the points where x is equal to 0, 1, and -1 for all 3 of these. Okay. So we are going to look at when x is 0, 1, and -1. Same thing over here. 0, 1, and -1. And same thing over here. If you end up not memorizing these 3 graphs and these 3 points for each of the 3 graphs, they're very easy to derive. You could just write it down and then choose 0, 1, -1, plug it in and see what you get. And you don't even need to do it here by hand. You could probably just come up with those answers in your head. Okay, so let's start with x squared. Okay, so when x is 0, 0 squared is 0. When x is 1, 1 squared is 1. And when x is -1, x squared is also +1. Okay, and let's do it for the other 2. Let's just go ahead and complete the table of values. So x cubed, when x is 0, 0 cubed is 0. When x is 1, 1 cubed is 1. When x is -1, -1 to the 3rd power is actually -1. Because -1 times -1 times -1. Okay, and then for absolute value of 0 is 0. Absolute value of 1 is 1. And absolute value of -1 is also 1. Okay? So let's go ahead and plot these 3 points and come up with the graph of each of these. Okay. All right, and let's get some tick marks going here. Don't need a whole lot since we're only going to 1 and -1. Okay. All right, so I'm going to go ahead and plot the first graph, x squared. So we have a point at 0, 0, a point at 1, 1, and a point at -1, 1. So we have these 3 points, and the graph of x squared has this U shape. Okay. And x cubed, we have a point at 0, 0, 1, 1, -1, -1. And while these 3 points here look like it's forming a line, it does not form a line. It has this sort of snake-like graph. Okay. And then absolute value, 0, 0, 1, 1, -1, 1. So we have these 3 points, similar to x squared. And here, instead of a U, we actually have a V shape. Okay. So these are the 3 graphs that we're going to be focusing on here on graphs of functions. These are going to be the 3 parent functions, and then we're going to translate these around the xy plane. Okay, so that's pretty much it for the graphs. If you just sort of remember, okay, x squared, we have these 3 points, 0, 0, 1, 1, -1, 1. And same thing with absolute value, 0, 0, 1, 1, -1, 1. One of them is a U, absolute value is a V, okay, shape. And then x cubed has this snake-like graph, okay? 0, 0, 1, 1, -1, -1. Okay? All right, so let's begin with our notes. So those are the 3 you'll need to memorize. Okay? All right, so family of functions. So we already know about the line. Okay, so, and instead of using y, I'll just use f of x. It's the same. Okay, ax plus b. So that's the line. You're used to seeing it written as y equals mx plus b. Doesn't matter what the letters you use for the constants. Okay, so this is your linear function. Okay, and so we know we get some sort of a line. And then we have quadratics. And we'll be looking at the quadratic a little bit more towards the end of the semester. So this is a quadratic function. And we know that is the u. Okay, and then the cubic function, degree 3, x cubed. So what we're going to be doing is looking at these parent functions. We've already looked at x squared and x cubed up there. And so this is just another way to write them. However, we won't be looking at them in this form, which is standard form, but we will be looking at them. Okay, and then of course the absolute value graph, which I will put down here because it's sort of different from the other ones. The other ones are polynomials. Okay, and this one's our absolute value. And this one is V-shape. Okay, so what we're going to be doing, so those are our basic functions that we are looking at here. And those are just, again, that's just like with linear equations, looking at it as in standard form versus slope-intercept form. So here, these are just sort of the standard form of the polynomials. Okay. So we are going to be looking at how do we graph these by translating. And so translating is just shifting the exact same graph. It keeps its shape, but then it moves around by shifting it either up, down, or left, or right. Okay. So, and we're going to be doing that with the parent function, which is why at the very beginning of the notes here, I said to memorize those 3 graphs, each of them having those 3 main points. So the parent functions, that we will be shifting around are going to be f of x equals x squared, and we'll be shifting that one around. And we know what that graph looks like. That's the u with points at 0, 0, 1, 1, and negative 1, 1. And we know what this parent function looks like. That's the snake-looking one with points at 0, 0, 1, 1, negative 1, negative 1. And also absolute value of x. And we know what that looks like. That's the V-shaped graph with points at 0, 0, 1, 1, negative 1, 1. Okay, and so let's just formally show that here. All right, so we had said f of x equals x squared. And so what happens is you'll be graphing. When we start translating these, you start off with the parent function like this, and then you'll be shifting this exact graph. Because again, translating it will keep the shape. It'll just move it. And x cubed will have these 3 points, 0, 0, 1, 1, negative 1, negative 1. And this has that sort of snaky graph. And then absolute value of x. So 0, 0, 1, 1, negative 1, 1. This is that V shape. Okay, so what we end up doing is taking the graph and shifting it. Okay, so let's list all the different translations. Okay, so if you have your function, pick any of those 3 functions. Okay, so you pick one of those functions, right? And if you add a number to it, okay, then you're going to end up shifting upwards C units. Okay, so for example, if you have y equals, and we'll just use x squared, if you have that parent function and you add 3 to it, you would be shifting that first graph up 3 units. Okay, if you have one of those functions, either x squared, x cubed, or absolute value of x, and you subtract a number, then you will be shifting this down. Okay, so for example, again, if you have x squared minus 3, okay, then you would take that graph and you would shift it down 3. And this is true for all of these functions. So if you had x cubed minus 3, it would be that middle graph shifted down 3. Or if you had absolute value of x minus 3, you would have that exact graph shifted down 3. Okay, so that's if you have a number added or subtracted to the actual function. Okay, what we're going to look at is also a sideways shift, a shift to the left or a shift to the right. And that happens when you have the number added inside the function, not outside the function. So here, it might seem a little not so intuitive here, but this here would shift it not to the right, but to the left. C units. Okay, so let me give you an example. So up here in these 2 examples, we see a number that's being added or subtracted outside of the x squared function. So here, the number would be added or subtracted inside the function. So you would have something that looks like this. Instead of x squared, you have x plus 3 squared. Okay, so hopefully you see the difference between this one, where you're adding 3 outside the function, and here you're adding 3 inside the squaring function. Okay, so whenever it's inside the function, so maybe it says x plus 3 squared, or x plus 3 cubed, or x plus 3 with absolute value around it, that's going to be a shift to the left. Okay, when it's inside, it's going to be a left-right shift. And we have one for subtraction. So this here will shift right C units. So here you would have x minus 3 quantity squared, as opposed to x squared minus 3. This is outside the function. This is inside the function. Okay. And again, if it's subtraction, then you go right C units. Subtraction inside the function. Okay. And then we have one more. It's actually a transformation. And this is, so when you have translations, it keeps the shape. So it'll have the exact same shape as those parent functions, and it's just moved around, either over to the left or up a view. Okay, this next one is a transformation, and this one will actually change the shape. And so this happens when you take your parent function, whether it's x squared, x cubed, or absolute value x, and you multiply it. Okay, so take whatever parent function, multiply it by some number k. And this will, this could stretch it or shrink it, widen it, but it changes the shape. Okay. And what happens here is you multiplying the original y values. Okay, so again, maybe you have something that looks like this. Y equals, and let's just use the x squared function. So whatever parent function you have, and you're multiplying by something. Okay, so here you would multiply all of the original y values by 3, and we'll take a look at that. Okay, so I won't graph this one, but I'll show you how this works. Okay, so for example, if you have to graph something that looks like this, and we'll graph this in my next video. So if you have to graph y equals -1 times the absolute value, x plus 2, and then plus 3. So what you will be doing is, instead of making a table of values, you're going to be looking at the equation, analyzing it, and figuring out, okay, well, which one of these translations and or transformations do I have in this equation? Okay, so we already see that we have this 3 being added to the outside. So we know that here, this is going to be a shift up 3. And then we see this one, which is inside the function, plus 2. So we know that's going to be a sideways shift. And this one's one that's a little counterintuitive. This is, so this is a shift 2 to the left. Okay. And then this one over here would be our multiply the original y values. Okay. This is going to either stretch it or shrink it, flip it. Okay. So before I actually do this one, we're going to go ahead and stop here. So these are just the basics. And in the next video, I will do 5 examples, including this one right here, where I do graph them. Okay, but I don't want to start with this one because this is a lot of things going on, but this is what you will be expected to be able to do. Okay, so let's go ahead and stop here, and we will continue in part 2 with 5 examples.